My name's Chris. I'm with V Studios, a small company outside of Tyson's Corner. I started off life at NASA Goddard a long time ago, doing robotics and AI, and then networking, and then I got into computers, and maybe 7 years ago bid on a contract to build NASA's first sort of public cloud for public consumption under the West Prime contract, now under East. And I haven't looked back. I really like the cloud stuff. And then when maybe a couple years ago we started getting to serverless, I thought, this is the shit. And I really like it. I'm a bit of a evangelist, maybe. Alrighty. So just agenda, what's the problem? Why conventional approaches don't work so well? Why we went serverless with AWS Lambda? And then started to go deep dive into the technology, our serverless architecture, how we address NASA security concerns, and then the benefits and a couple drawbacks of going serverless. So the problem. On a spacewalk in 2013, astronaut's helmet started filling up with water. There's a video of it where he's talking about not being able to hear, not being able to see, not being able to breathe, where the water's coming from. In typical NASA fashion, though, he's super calm about it. But the guy's got this much time to live. They managed to get him into the space station, take off his helmet, he's okay, but they need to find out what the hell went wrong. The problem is, NASA doesn't do space flight hardware in an agile manner. And that's a good thing. They don't send an astronaut out and say, well, spacesuit failed, well, fix it in iteration 2. A lot of the designs are pretty old. They're from contractors, multiple different contractors. They're on paper. There's designs, there's technical reports, there's testing reports, and these are on paper, and NASA scanned them, but no OCR. So for a particular piece of hardware like astronaut helmet O-ring seal, they have to go into the vaults and find out which version he's wearing, which connectors, and all the assemblies that use it, and the sub-assemblies that make it up. This obviously doesn't scale. It's hard to resolve a problem quickly when you've got paper in the vault. I always picture this as sort of the end of Raiders of the Lost Ark, where there's a warehouse full of boxes full of files. That's what they have to go through. And actually, we talked to some of the EVA people, and they said, oh yeah, when Fred's on vacation, we can't get that information because he's the guy that knows where that part of the spacesuit lives in the file cabinets. It's ridiculous. They have 100,000 pages of test and analysis and verification reports from engineers they need to process every month. If you see a picture of it, it's the size of half a shipping pallet of paper. It's that big. They started trying to OCR this a while back, and they said, it just crushed their system. They've got a system that's in the cloud, but it's just sort of a basic mirror of a data center type of application, a couple servers, and they feed a couple of databases, and that's about it. And when they tried processing this much information, just using plain old OCR techniques, it just overwhelmed it, backlog, everything else they're doing. So they said, screw it. We'll just OCR the first page of each report, so at least we have the part number and the assembly it belongs to. We happened to run into one of the guys from the EVA office. It's fairly high up, and we worked with him before. And he said, what are you working on? I said, I'm doing some serverless stuff with OCR. And he said, that's funny. Let's talk. And that was the genesis of this work. So conventional approaches, as they found, don't work so well. You've got a data center. You've got a server on your desk. You feed it a report, maybe a few 500-page reports, and it can handle maybe one. Then you feed a lot more, and it just falls over. It can't handle it. You're not going to scale up in your data center, probably. So you can move that to the cloud. Still won't scale up unless you use cloud-type technologies, and that's good. And that's actually what I'm picturing here. Typically what you do is you have a high volume of inputs. You feed them into a queue. The queue buffers them, and then you have an auto-scaling group of EC2 instances that grow with the CPU load on the instances or with the queue depth, how many jobs are waiting. And they scale up and down. New machines are launched, and they process the PDF document, scan, and they send out their text somewhere. It's pretty good, and it's exactly the architecture we used for building images in NASA Gov. It's classic auto-scaling type of application. Problem is, the auto-scaling is a pain in the ass to set up. You've got to have all these different private and public subnets and ways of getting the data in and out, and then scale up, scale down rules, cool down rules, and it actually takes 5 to 10 minutes to scale up an instance after you've said, okay, we've got 60% load, let's bring up another instance. It just takes that long for it to boot up. It's not a big deal, but it's complexity that I don't want to have to manage. Containers, Kubernetes is hot, has the same kind of architectural pattern, but you have a lot more complexity. You've got clusters, pods, nodes, placement issues, and scaling. And I'm not a fan of worrying about stuff that doesn't deliver business value. The Kubernetes story is like, if I'm going to use Kubernetes, I want someone else to run it and manage it for me. I just want to throw software at it and say, go run. If only there was a better way. Turns out there is. Serverless with AWS Lambda worked out really well for us. So serverless, I like to think, is service full. The naive, snarky people say, well, there's servers in serverless. Of course there are. You don't have to manage them, and that's the best thing. And it's not just serverless, which everybody thinks is like Azure Functions or AWS Lambdas. It's services that you use, but you don't manage, you don't secure, you don't pay for, except by the use, by the minute, by the megabyte. So there's services like compute, AWS Lambda. There's databases like Dynamo Db that when you stop pumping data through them, they don't charge you anything significant. There's authentication services like Cognito. There's lots of other services within the cloud provider's network that you pay for basically by the use, and that you don't run, you don't secure, you don't worry about, and that's really liberating. You can concentrate on your problem. These are all managed by them: security, scaling, patching. You don't pay for idle time in the classic data center or even in the cloud. If you got a honking raft of EC2 instances running, and they're not processing data, they're costing you money, and you're getting zero return. So build business value, don't build infrastructure. Your customers are not paying you to build infrastructure. It's just a necessary evil. If you can avoid building infrastructure, do. So AWS Lambda is event-driven computing. This means that something happens, and a Lambda triggers a Lambda. A Lambda wakes up, and it knows what code you've told it to run. It processes the event, and goes away. And during that 1/10 of a second, 2 seconds, 15 seconds, 5 minutes that it runs, it's charging you. But the minute it turns off, it stopped charging you. This is a huge win. So examples of pushed events are like API gateway, where HTTP connection will come in to API gateway and maybe say, get me the weather for the zip code. And it launches a Lambda. The Lambda goes out somewhere to the weather service and gets the weather and then sends it back to API gateway, then gives it back to you as HTML or JSON or something. Simple storage service, S3. Classic pattern is you drop an image on S3, it fires an event that launches a Lambda that does a watermark or a resize for you, and then puts it somewhere else. Simple notification services, CloudWatch events and logs, Cognito authentication, or Alexa. If any of you have Alexa devices, when you say Alexa, give you the weather, what it does is it triggers a Lambda to go out to the weather service, it knows your zip code, comes back and tells Alexa what it is, and then Amazon Polly speaks it to you. That's how they can handle all these silly Alexa devices cheaply. Pulled sources include Dynamo Db, a cloud scale NoSQL database. That's really neat because if a record is added, deleted, changed, you can configure the Dynamo DB to emit a stream for every change, and that launches a Lambda. You can think of this as sort of, if you're an old school SQL person, as a stored procedure type of call, except you can write the procedure that handles the row in a sane language that isn't tied to your database vendor. This allows lots of cool stuff like database replication. You can replicate everything that happens in your database over to, say, another region, another DynamoDB, or you can maybe feed it into Elasticsearch after massaging the data. So every time a new record comes in, you feed it to your Elasticsearch, and now you've got a record of it in DynamoDB, and you've got a searchable endpoint Elasticsearch. Simple queuing service, a neat thing about that is like from the architecture before, where you've queued up a bunch of things that need to be handled. The neat thing about that is Amazon will automatically scale out or pull faster rather based on the depth of the queue. If you've only got one item in the queue, it pulls like 5 times a second or something. If you have hundreds of items in the queue, it pulls much faster, so it launches more Lambdas to drain that queue faster. And this is all handled for you automatically, so you don't have to worry about it, which is great. Kinesis data streams. And custom invocations. You can have an EC2, you can have a Lambda, you can have your desktop computer invoke a Lambda to do something. Just an API call, you say, here's my data, and I want you to run synchronously, and I'll wait for the results, or I want to fire and forget, and I'll run you asynchronously. I expect you to put the results somewhere useful. If you start using these events to trigger, if you break down your monolith into, instead of functions that pass things around, big data structures, if you instead use events to trigger Lambdas, you start breaking your monolith down into small microservices, and you get sort of a function as a service model. It takes a bit of rethinking, though. So here's the architecture we use to try and process these scans and turn them into actionable text. So the really nice thing about this is that AWS Lambdas auto-scale beautifully. If I feed it more triggers, it spins up more Lambdas. If I feed it even more triggers, it spins up more Lambdas up to the limits of your account, which is about 1,000. So what we first started doing is we had a whole bunch of PDF reports, maybe 500 pages each, and we threw them at Lambdas. And the Lambdas all fired up. The more reports we threw at it, the more Lambdas started up, and they generated the text output and put it somewhere, and it's like, hunky-dory, this is great. MVP. The scaling happens instantly, and you don't have to configure it. Unlike EC2 auto-scaling groups, which are a nuisance, this just happens. And that's, I think, the way it should be. There's no logins, there's no patching, there's no ports open. It just runs your code. The Lambda basically, when it wakes up, says, oh, I see, I'm configured to run this Python code or this Node code or this Java code, and just runs it. There's some limits on the languages. There's maybe 6 or 8 by now. Code size and time, a little bit more on that later. The big insight we had, though, was that each of these reports, like 500 pages long, if we split the 500-page report into 500 separate pages, then each of those pages could launch its own Lambda. So now you have 4 reports coming in, 500 pages in parallel, so now I have 2,000 Lambdas running in parallel, and it just wails through. And it took we just split the code up into 2 Lambdas instead of 1 to split, 1 to process, and the auto-scaling just happens automatically. It was trivial. It was so gratifying to see. The neat thing about this is, let's say it takes a second to OCR every page. If you have a 500-page report, and you're just doing it with 1 Lambda, it takes 500 seconds, and you pay for 500 seconds. If you split it up, you have 500 Lambdas, each taking 1 second, you still pay for 500 seconds of processing, but you get it done in 1 second, which is fantastic. Doesn't cost any more, and fairly easy to re-architect. So, how do we leverage the event-driven to change from sort of a monolithic application like they would have been using, ingest a document, process it, store it, into doing something in a workflow environment? I'm really cheap, so I was trying to do this quickly and cheaply as possible, so I didn't want to have any database tracking. I was trying to figure a way that we could manage the workflow without bringing in a database that just adds complexity. So on the left is the EVA Office's data integration server that has all these reports. It drops a PDF document, a report, 500 pages, in an S3 bucket we own, under a prefix called PDF docs. That prefix is configured to launch a Lambda whenever anything gets dropped into that prefix. That launches a Lambda, which pulls down the document, splits it into 500 pages, and then drops each of those 500 pages back down into another prefix called PDF pages. That prefix is configured to launch another Lambda that does the actual OCR. So the first document comes in, 1 Lambda launches, put pages down, now 500 Lambdas launch. Each of those 500 pages drop the text down into another folder, text pages. Those launch 500 parallel Lambdas, and that one's actually the most difficult one. It says, I've got 1 page, I've got 2 pages, I've got 3 pages, because these pages all come in out of order. It has to check and see how many pages it has, and if it's a 500-page report, it knows how many pages it's supposed to look for, but it has to count, it's got 1, I got 2, and it has to keep track of them somehow. When it finally finds that it has, okay, all 500 pages are done, great. I'll then download all the pages of text, create a JSON file with document name, page 1, text, page 2, text, page 3, text, and it drops that down onto the last prefix in S3, text docs, and that triggers the final Lambda, just 1 this time because there's only 1 document, which slowly feeds the pages to EDI's search API endpoint. And that's running Elasticsearch, and we have to spoon feed it. Here's page 1, here's page 2, here's page, 500 error, damn it. But the folders allowed us to define, using these folder-based triggers allowed us to define a workflow without having any database tracking or anything. There is a trick which we used, which was like, when we split, we knew how many pages were in the original document. So we attached to each of the S3 objects that we stored, every page, every PDF, everything, the maximum number of pages we're going to find. You can store maybe 10 or so data points or metadata objects in an S3 object that aren't part of the object, it's just metadata about it. So that's where we store the original file name, the maximum number of pages, and a couple other things, like the user who submitted it. So again, no database, lots less complexity. So go ahead, please.
Do you mind explaining one more time how you know when all 500 pages are together? I didn't quite catch that.
I have a really sleazy hack. Good question. So we're putting these pages down onto the text pages prefix, right?
Okay.
So each text page goes down and launches the "Are we done yet?" combined Lambda. What it does, and this is gross, is it goes to the S3 directories and lists the directory and counts how many files are there. It says, oh, I got 499 files. Not yet. Oh, I got 500 files. I'm good.
Okay.
And the thing that really hosed us, like 2 days before going production, was when we started throwing tons of data at it. These triggers aren't guaranteed to be one-to-one. You're guaranteed to get at least one event. We were getting 0.1% of the time. An extra thing said, I got a page. It's like, uh-oh, we got 501 pages now for a 500-page document?
Right. We've seen that in the past as well, just that occasional extra.
Yeah, so there's two ways we could have handled it. We didn't expect this, and the documentation is very vague about it. And I finally realized if you go read the SQS documentation, it says you get at least one notification. So they're using a SQS under the covers. They wouldn't say it, but the guys are sort of like, could be. So knowing that, it's like, okay, so there's two ways to defend against it. The first way is to say, it's a bogon. We're just going to ignore it. What we chose to do is every time we received a file, we put down in another place in S3 a checksum of that file, like the E tag, basically. So before we processed a page, we'd say, did we already get this one? Let's look for the E tag. Oh, we already got that one. Just terminate the Lambda without doing anything. That was our way of saying, have we already seen this? It's echo detection.
How did you ensure that it was from the correct batch? I mean, it was like the second batch of 500, page 2.
So we need the prefix to be these exact prefix names in order to create the event. But under that, we would have like a job ID.
Okay.
And then everything under that was part of that job. So we knew we could associate each of these with a specific job instead of some other job. Okay. So we'd have like text pages / job 34 / 0001.text.
Gotcha. Thanks.
Sure, good question. And I was kind of glossing over how sleazy that approach is. In the future, we were thinking for larger scale using Dynamo DB, but even doing that is difficult. You have to be careful to do an atomic increment, and you can't have two different lambdas incrementing, and then you get a race condition, so you have to be very careful about that. Or they just yesterday introduced a dynamic mapping for step functions, which we're starting to use for orchestrating lambdas, and that I think should really help.
For the OCR portion, are you guys using comprehend, or what are you?
We're using the hard part. One of the hardest part of this was we're using Tesseract. Is compiling Tesseract to run on the Lambda OS, and getting all the libraries it needs. That was a pain in the ass. Now with Lambda layers, somebody's already published a layer pre-compiled for that you can use, which is nice. So we would use layers now if we were to do it again.
So is that on a custom runtime or one of the supported ones? Or?
It's one of the, well, I think their layers are on supported runtimes. We don't want to manage infrastructure, so we're happy to use their runtimes. But we just had, so there's a thing called LambCI, which is a CI/CD system built on Lambdas, but they published a Docker image that is basically as close as you can get to the Lambda image as possible. It's got all the same libraries and everything else. So if you launch the LambCI image in a Docker, you can use that image to then compile your stuff like Tesseract or libjpeg or Leptonica and whatnot. It's a nuisance, and it's something I don't want to do, but now with layers, somebody else has already done it. At the time, they didn't. And then, of course, at the time, we had like Tesseract 3, and now they've got Tesseract 4 Alpha, and then trying to fit that. Tesseract's pretty big. Trying to fit that in the Lambda image space is difficult, but it worked.
How are you handling errors with the OCR layer if you got like a corrupted page or something like that?
We pretty much just log it and move on, because if we just fail, then the thing that's waiting for the document to complete will never complete. So the best thing you can do in that case is just emit an empty document, and then that can be tallied up as part of the 500 pages.
Yep.
I think with using a step functions workflow, you'd have the same issue. If your step functions workflow with this new thing called map is dynamically sized based on the number of things that you're outputting, if any one of those fails, it fails the whole workflow. So probably for us, it'd be better for the customer to just emit a blank page and a log that says, sorry.
And then just keep a running log and then you can go check
Yeah,
later, see what
yeah,
happens.
maybe assemble that as a report at the end saying, we got 499 pages, here's one that didn't work. Because we've seen PDFs that actually have Excel tables in them. That's unbelievable what people put in PDFs. I mean, an actual Excel table is a subdocument.
Have you looked into, following that vein, have you seen TextRact at all?
Yes,
or have you
we're
tried
using
it?
that now for another NASA project, a grant to do more structured extraction. We've done a side-by-side comparison of Tesseract 4 with the neural network and TextRact. They're both, for basic blob of text documents, comparable, very comparable. I was pleasantly surprised at how good Tesseract was. But for doing structured text, Tesseract can't touch it, because that's not what they're focused on. But frankly, I'd rather call out to TextRact now than bundle in Tesseract, because it makes my Lambda lighter weight. One less thing for me to do. However, it's not in GovCloud if you're doing government work. Ouch. Yeah. It will be. So NASA's got lots of security concerns about this kind of stuff. I expect most of you do. Lambda is still, after a year or whatever, still is not FedRAMP certified in GovCloud. It's there, but it's not certified. So we worked with our security team, who's actually pretty reasonable, to get an authority to operate in our GovCloud. So they required us first to run in GovCloud, and that's fine because that's where the rest of the EVA office's IT systems are. All the spaceflight hardware stuff is ITAR controlled, so they have to run it in GovCloud. They wanted us in a separate VPC. Our Lambda's in a separate VPC from their infrastructure. That turned out to be a winner too, because we first deployed in their VPC. Their VPC is like a /24 or something. That had 256 IP addresses. Sounds big if you're only running 6 servers. We immediately blew that out, launching 1,000 Lambdas just with the first document we submitted. It's like, what the hell are you doing? And we said, well, give us a bigger space. It's like, well, we can't. It's like, can I just have an RFC 1918 address space, please? It's like, no. And then the security guys came in and said, you have to be in a separate VPC. And I said, make it big. It's like, okay, fine, no problem, thank you. And now we've got plenty of space there. And that's a pattern a couple other people have said that they've used exactly for the same reasons.
So when you spin up the Lambda, it's attaching to your VPC, so
Correct.
no VPC attachment?
Yeah, it gets a network address in the VPC.
Okay.
Now, in a second, 1 second, you're leading the witness.
They're rolling out and change that.
Yeah.
Yep, that's going to go there.
Yeah.
So they wanted to put us in a VPC so they could make sure there's no traffic getting out. So there's no network egress from this VPC. It's like, it's a box. That made them happy that we weren't leaking sensitive data. We used EM, identity access management, roles and policies to restrict access between our systems and their systems. We use security groups to allow us to talk to their final submission engine. And we encrypt the data in transit and at rest on S3. It's pretty easy. And they run some static code analysis against our Python code to make sure we weren't grotesquely insecure. S3 VPC endpoint was really nice because then we could get our stuff out and into S3 without having to set up a NAT gateway. And they didn't want a gateway anyway because that would have leaked data. And we used S3 lifecycles to remove documents after 24 hours. If there's anything not being processed in an hour, we should probably just nuke it. Something's wrong. So Lambdas are currently under Joint Authorization Board approval. It's been that way for a while. But Lambdas, until maybe last week, Lambdas and VPCs were not best practice. Because when you're in a VPC, it takes a while, like up to 30 seconds, to attach Elastic Network Interface to your Lambda. Now, normally with a server that boots up and stays there for weeks or years, that's not a problem. For this, where you're launching thousands of them every minute, second, it's a real problem. It's a huge hit. But just last week, they announced some huge improvements where I don't know how they're doing it, but there's a couple of good technical blog posts about how pre-attaching or pre...
Instead of going outbound with that, they're basically creating a NAT gateway inside inside of Lambda, so you're going to funnel through that, and it's a quicker spin up of the network interface instead of trying to attach that ENI across.
Yeah, I think, this is the Lambda nerds went wild when they announced this because they've been waiting for it, right? Because it's a killer in VPCs. And a lot of us have to work there, not because it's a good idea, it's just because our security people think they're afraid of it. But the rest of the serverless resources, Dynamo DB, S3, and the rest of it, they live in a non-VPC space. They're in their own service VPC. So you're not gaining any security by putting them in a VPC, but they're making security people comfortable that they can see no traffic sneaking in. So it's a huge improvement for I think, VPC-bound Lambdas. So how do we integrate securely with them? Like a lot of other people who are not yet cloud native, their servers talk to each other over HTTP, fine, and they authenticate to each other using service accounts. Like, oh, here's my EDI Elasticsearch account and password. I'm logging in, I'm going to give you a document. And you say, okay, let me check this username and password with NASA's central authentication system. 3 seconds later, okay, you're in. We knew that was going to be a horror show to write the code for, and it's going to completely destroy any kind of performance on this. Further, we knew it would destroy NASA's centralized authentication system. It simply wouldn't be able to handle thousands of connections a second with all these Lambdas launching. So we looked and said, well, why don't we do it in an actual cloud native way? So starting on the bottom left, we have a policy that says, we call it like S3 write document PDF. And it allows us to write to our specific S3 bucket in a specific prefix, the doc PDF prefix. That policy is attached to a role called an EVA app role with any other policies that they may have on their EC2 instance. That instance now has the ability to submit a document to our S3 bucket just in that prefix. So that's really tight. They can't write anywhere else on our S3. That's good. They can give us garbage. They can give us a Word document just, with a PDF suffix, but that's on them. Now on the bottom, we have all of our Lambdas with a role attached to them. And the role has there's a security group as well, and it's just a named security group. It doesn't describe any policies, it's just a named security group. We treat it as a marker interface. The role first allows our Lambdas to talk to all of the locations in the S3 bucket, read, write, anywhere, because that's what we do. Now, we could restrict each Lambda to just the input and output prefix we need. That'd be a little bit tighter. It's probably what we should do, but we weren't that worried about it. But that's, the nice thing is you can apply specific policies to each of your Lambdas if you want to really tighten it out, something you couldn't do on, say, an EC2 instance that does everything. We attach this security group that doesn't have any policies to it, and when that last Lambda outputs to EDI's Elasticsearch, it connects to a port that they've told us to use, and on their system they have a security policy that says, allow anything with our named security policy to attach to us on port 533 TCP. So we can't go out anywhere else. We can't connect to any of their other ports, and they aren't letting anything else attach to their port because of this security group. It's really pretty tight, and we never harmed any of their auth servers building this. Yeah?
Are you required to encrypt your S3 buckets?
We weren't initially, but we thought it was a good idea, and we did it proactively, and we went in front of the security guys, and they said, nice work. So I think by being a little bit proactive with the security people, they appreciate it, and they worked with us to get this going. They finally did give us the ATO, and life's good.
It's free.
I know.
Turn it on.
Just do it, but then it's like, my uploads are failing. It's like, oh shit, I forgot to turn on the encrypt on delivery option.
But are you using a KMS to manage the keys?
No, we're just using their own built-in security encryption thing. I can't remember what it's called. ESS, and I can't remember. That's it, SSC. Server-side encryption?
Yeah.
No. Yeah. Yeah, we could have managed our keys, but again, this was a fairly short-term project, end of fiscal year type of money project. And just doing any encryption was enough to keep the security people happy, and I don't want to manage the keys. It's something else to lose. Yeah.
Is the EDI search API, is that running on Amazon Elasticsearch, or is that like an open distro, or what is it?
No, they're running their own. They're running an ancient version of, or they were at the time running an ancient version of Elasticsearch because they had a whole bunch of like custom libraries in front to do, I think, authentication. I was like, oh, let me go check NASA's centralized authentication server to see if you're allowed to submit.
Yeah.
So all these libraries were bound to the old Elasticsearch. They're now looking to use the Elasticsearch service because who wants to run your own?
No,
but I
it's
think
the role to actually push the data instead of having to go over the port, right?
Say it again. I'm not sure I got that.
If you're using the Elasticsearch service, you can use a role, I think, to push the data.
Yeah, but the rest of the group was at that time not at all understanding that cloud has different things you can do. They could have dispensed with these service accounts if they knew about EAM roles and policies, but they didn't know about them, so they were just basically lifting what they had in their data center into the cloud. So we figured we'd show them a good path, and I think they're working on that now. They got some good people there. They've got more cloud smarts to do this kind of stuff. So I mean, you need to work with the people to bring them up to speed, because otherwise they won't understand and they'll get scared and they'll say no. So we saw a lot of benefits and a couple of drawbacks, but the drawbacks weren't showstoppers by any means. Lower cost. We estimate that this probably saved us 80 to 90% versus having a bunch of servers running, even auto-scaling servers, which you could scale down to like 1, maybe 0 if you're clever. It's so cheap, serverless, like setting up a bunch of S3 buckets and a bunch of Lambdas. When they're not running, they're literally not charging anything. So what we're doing now is we're setting up CI/CD environments for our repos that when a developer commits, it creates an environment for that developer for that feature branch. And then when you merge down, it merges it and creates an environment for the dev, and you can run all your tests in a separate Amazon environment. The scaling is fast, it's automatic. I don't have to worry about it. It's so much faster than EC2, so much less of a headache. I don't have to manage the infrastructure. I just define it. They do all the security. The security people can't rake me over the coals for something I don't own. And they can look at Amazon and say, oh, you're FedRAMP this, and you're FISMA that, and you're all these other certifications to make them happy. We use the serverless framework. It's actually called the serverless framework. It's not the Amazon SAM. It's been a joy to work with, and serverless framework came out before SAM, and they have innovated so fast. It's really good stuff. They've now got a dashboard feature and a bunch of, they're trying to basically go enterprise with it, but it's gorgeous to work with. Basically, you define some stuff in a YAML file, your resources, your triggers, your lambdas, and point at your code, and then you say serverless deploy, and it creates a CloudFormation template and then builds everything in the cloud for you. It's delightful to work with. And if you just have you say update your Python, you say serverless deploy my one function, and it doesn't have to create any new infrastructure, it just deploys the new code, so it's very fast to get the stuff up. It allows and demands a new way of thinking. It took me a while to sort of like, when somebody told me about this thing, it's like, why would I want a serverless thing that only runs 5 minutes? I can't do anything in 5 minutes. But then I realized, oh right, if you treat each Lambda as if it was a single subroutine call, it makes sense. Your subroutines in a monolithic application are only going to run for a quarter second, a couple seconds maybe. So you have to think about how to define things in an event-driven way. And now I sort of start approaching problems like that. Instead of thinking of them as the monolith, I visually break it down in my head, because it's easy to break it down into parts that way, I think. You invoke each event with a trigger, S3, Dynamo DB, or another Lambda. And you get this sort of function as a service architecture. So there's some drawbacks. I don't think they're very limiting, though. The language you can use, Python, JavaScript, Go, PHP, C#, Java, Ruby, PowerShell. They've now got some, you can build custom runtimes, but again, why would I run a secure and build and manage and be responsible for my own runtime? I'm fine with Python, thank you. The run duration originally when we were doing this was like 5 minutes, now it's up to 15 minutes. Again, if your Lambda's running 15 minutes, you're probably not breaking your problem down enough. Memory and disk, this for some of the other applications we're working on can be a problem. For images in AstroGov, we want to go serverless with it, but we have to do a lot of video transcoding. We're not going to do a 5 gig video, transcode it on a Lambda. There's not the memory, there's not the RAM. There's some clever people out there who are taking, I think it's Vimeo, they're taking large videos and splitting them up into like 1 meg chunks and then transcoding them on Lambda and then assembling at the end. That's pretty slick. I'm surprised it works. So if you have these limits and you're really bumping into it, maybe break down your problem or try and parallelize the data set. Vendor lock-in. This is the first thing that all the bean counters it. But what about vendor lock-in? If you use Lambda, you can't like take that to Microsoft, and you can't take it to Google, and you can't put it in your data center. It's like, right. But if I'm in the cloud, I should better be using SQS and Dynamo DB and Cognito and all these other services that the vendor's providing. Otherwise, I might as well just stay in the data center, and then I have to write my own queuing system, run my own queuing system. I don't even have EM authentication and access control mechanisms. I'm not using my vendor's stuff. So I think once you commit to a vendor, just commit to it. Don't worry about the FUD. It's nonsense. I think there's the concept of data gravity. Once your data's in the cloud, you got to do your processing there. I think for cloud stuff, it's not about data gravity. It's about knowledge gravity. If you are now pretty good with building systems in AWS, you're not going to move to Google. You're not going to move to Azure. And you're sure as hell not going to do multi-cloud. That's just a recipe for disaster. So I think avoid the FUD. Just build with the systems and platforms you're comfortable and leverage everything your vendor provides. Don't build anything you don't have to. Don't build transcoders if you can use theirs. Don't build queuers if you can use theirs. Local development and integration testing, yep, that's harder. You can do unit tests, but your laptop is not a cloud. You can't do everything that the cloud offers you, otherwise there would be no reason for Amazon or Azure or Google. There are some neat things out there. There's a serverless application model, SAM Local from Amazon, where some of the services are running on your laptop. There's Atlassian's, Local Stack, which again emulates some of the stuff. I'm using Dynamo DB Local to do a bunch of testing of data modeling, and that's super helpful. But I'll do my unit testing on my laptop. But then, because again, deploying into a serverless environment is so cheap to run, I can do fully reality-based testing there. Because the thing that bites you in the ass more than anything else is not just your code and logic problems. Once you get that solved, it's like, oh shit, this thing can't reach to that thing because security group blah or EM policy blah doesn't allow me to read from that Dynamo database location. You're never going to be able to model that on your laptop. So the things that are really hard, you're only going to find out in the cloud. So just deploy it to the cloud. Be happy.
It's easy to point it somewhere else and deploy it there.
Yeah, it's pretty fast too.
Your test area.
Yep. Again, every developer can have their own test area for every feature branch. It's cheap. There's some people that have built smarter CI systems than me that on every feature branch it creates a new environment, and then when you merge the feature, a hook tears down that one. I'm being a little bit lazy. I just say every feature branch, it says, oh, this is Chris's feature branch, so I'm just going to deploy to the environment called Chris. So every developer gets their own environment. At least that prevents me from stepping on somebody else's toes. It's just so cheap. What you will find, probably right away, is that you're going to overload external services. The authentication service that I talked about, if you're writing to an SQL database, you're going to kill it. It's not designed to handle thousands of reads and writes connections simultaneously. Our enterprise, the EVA's data integration, their Elasticsearch, we thought we were great in testing. We were just like submitting to something locally that we were running. But then when we started talking with their system, it's doing some other things. So we'd write, page 1, page 2, page 200, and then just go, 500 error, 500 error, 500. It's like, okay, now what do we do? So you can in your Lambda, check for the errors when you're talking to a downstream provider and back off. You may have to do some clever things where you set some kind of checkpoint. I think what we did is we put a marker on our S3 file saying, okay, we delivered up to page 200, and we killed the Lambda and caused another one to spawn up. And that looked and said, oh, am I checkpointed? Sure. Okay, I'm going to start at page 201, 202. So you may have to do some restarts to handle downstream providers that are just not going to keep up with this. All right, the big wins. Most important thing they wanted to be able to OCR and get the data out of every page of every report, and we've given that to them. They're doing 100,000 pages a month. It's in production. It's been in production for over a year now, and I don't know how they're using it, but they're able to search all their stuff and bring up all the text from all the pages of all the reports. I think I mentioned we're now trying to work with them to take more structured data out of tables and out of forms so they can do more sensitive queries like find me all the documents that have assembly number 5331212 instead of just like find the word 5331212 somewhere in a document. I mentioned we had end of year money. It's like, okay, I got this idea. Can you build it? It's like, yeah, I guess so. How long do we have? 2 months. And the paperwork took 2 weeks. The implementation probably took about a month, and then we got burned by this event echo phenomenon that we had to solve very quickly. But the hardest part was probably working with security to get them comfortable and to change the architecture a little bit to comply with it. And the real hard part was convincing the prime contractor who sort of ran the cloud that we should be allowed to use Lambda at all. I was like, well, nobody else is using it. I was like, well, we need this. And it really took us a while to persuade them that it was safe and cost efficient. They're saying, well, how are we going to build this? We have to put in monitoring software on all your Lambdas. The monitoring software costs more to run than the Lambdas did. And I said, like, this meeting we had with 10 people, that just cost more than a year's worth of Lambda. Just back off. Don't build them. It's that cheap. So, I mean, we figured that like a month of 100,000 pages is about $200. And if we tuned our Lambda sizes, we didn't have the time to just do a history of seeing how many, what size document requires what size memory. Maybe the splitting takes the most memory, so we'd use a big Lambda for that. Maybe a single OCR for a single page takes very little memory, and smaller memory Lambdas cost less. If we could profile that, we could probably drop this price to $20 a month, which is just ridiculous. It's not even worth billing at that point, really. It's super fast, and it's very flexible because you're building these microservices, but you just have to, trying to diagram it all and get all the triggers and events working, that interconnection then becomes the hard thing to manage rather than a monolith. So our customer is pretty happy. I guess happy enough that he's asked us to come back and build more stuff for him. And I guess maybe 6 months after that, the head of NASA, the administrator, gave us an award for the pioneering work we did on this team, which is pretty cool. And normally we think like cloud first, but now I think our approach is like let's do serverless first. If we can do it serverless, do it. If we can't do it serverless, what parts can we do most of it serverless, and then maybe farm out the big things like to Fargate or something. Yeah.
I just want to mention our award was for being the first production serverless app deployed by NASA specifically.
Yeah. So it's, they had a couple like little Lambdas that would like go and check on boxes and say if you don't have the tag, we're going to turn off your box. But this is the first actual application and first application with a NASA, serverless application with NASA running on GovCloud.
He says it's been in for a year.
Over a year. And no complaints, which is really great. Yeah.
Quick question, you had mentioned logging earlier. Are
Yeah.
you using anything other than CloudWatch for that, or?
No, I think the security group, they run a Splunk aggregator. So they're probably harvesting the stuff from CloudWatch and putting it in an aggregator. They don't let us see that though. There's, especially with GovCloud, they wouldn't let us get a console or do anything else. We had to walk through this pinhole to do any deployment or anything else. It's a nightmare. That was why it took 2 months instead of like 3 weeks to do this. Because we had, Mother may I deploy this function. Mother may I see the logs. No. Can I see it now?
Do you have any failures? How do you get hold of the cloud? Do you have to submit a request to look at them? Or?
The serverless framework has a little thing called serverless log tail function name.
Okay.
That was helpful.
I was going to ask about like operations side of it, like when things are going bad. So I guess you have to kind of work around the system.
If we had more visibility, we probably could have done better. We did set up for each of these lambdas what's called a dead letter queue. If a lambda fails, it can drop the event that it. So lambdas, if they fail, they typically will try once, twice again. They'll back off because I think they hope that it's a transient failure. You can either trap it and say, no, I meant to fail, or you can just like let it fail and let Lambda retry. And so it backs off, retries. But then if it uses up all of its retries, it'll drop the event that caused the problem in a dead letter queue, and then you can go look at that later. So we set up a CloudWatch alarm that when anything got dropped in the dead letter queue, we'd get an email saying something bad happened, here's the event. So it's like, there's somebody dropping a Word document into the PDF directory. Can't imagine why that would fail.
Were you able to track what kind of parallelism you actually got in terms of like you farmed out 1 million pages to Lambda?
We didn't have visibility. I mean, when we were developing in non-GovCloud, and it was easily hundreds.
Okay.
Yeah.
Got another one. So are the PDFs still like being created today, or are they like moving away from like having PDFs and they're able to integrate their new knowledge directly into their search API?
From what I don't know if it's backlog of paper, but what they're giving me now, what we're working on now is like these forms and tables. It's paper, and so they'll have 10 contractors working on the spacesuit, and each contractor gets to design their own shape of form, and each contractor gets to call part number whatever they want, part num, part now, ASCII number sign. So, no, NASA can't even dictate to the contractors what they call a part number or what the shape of the form is. So that means that taxpayers have to pay people like us to try and do really hard work to extract this out. And I think, the Raytheons and General Dynamics of the world, they're not in any hurry to provide things in an interchange format that other people can use because, my God, if Boeing gave it to you in JSON, then McDonnell Douglas might take it and put it in their system. Horrible. They might cooperate. It's terrible.
Yeah.
And I think that's probably true with airlines and cars.
Okay.
Yeah.
When you were talking about, like, it's hard to kind of figure out how all the pieces fit together. If you had a new developer come onto your team that wasn't there when the initial solution was developed, what kind of information could you give them? What kind of documentation? Did you kind of roll your own? Are there tools that you've used to kind of give them an overview?
I'd give them lots of diagrams, like the architecture diagram that I had back here, and I have two different diagrams that we gave to our ops people. It's like, here's the one with the data flow, where it showed like the data flowing between this prefix and this prefix and this prefix, and here's the interconnectivity between the systems that's more for the security people. This architecture was actually pretty simple, intentionally, but with much, much more complicated designs. I think it's on you. I don't think there's any automated tools that can draw all this, although I would not be surprised if the serverless framework people weren't coming up with a way of taking that description, what gets turned into a CloudFormation template, and creating a diagram. And I think Amazon already has a thing in CloudFormation where it'll take your definition and give you a visual display. That doesn't quite tell you all you need to know because it doesn't understand about triggers properly. And also CloudFormation it always lags. They deploy products without CloudFormation support.
I had to roll my own too. I was just curious if you solved that.
No, I wish I did. I mean, even coming up with the nomenclature for drawing, that visual vocabulary is difficult at that complexity. Doing something much more complicated, like we want to do images in ASA.gov that way, and it'd be much more complicated.
Okay, thanks.
Sure, good question. Wish I knew one. Yeah.
I guess it's a kind of a two-part question, but do you think going back for your next project, security is going to be more forgiving for the kinds of stuff you want to do, like looking at a console? But also a related question, second part is, anybody that you've shown this presentation to, any government agency person, do they take this and they go, wow, Lambdas, I never thought of that? Is the adoption of AWS becoming much better now?
Well, it's AWS and Lambda. I think people are saying, okay, we can move to the cloud. And what we've seen when we built this cloud infrastructure for West Prime 7 years ago, we're in the cloud, we can check the box. We moved our Oracle database into the cloud, and we moved our Cold Fusion app into the cloud. We're cloudy. Aren't we cool? And you're still spending $300 a month on server cost. You're not saving any money. You're not providing any resiliency. So I think people move into the cloud because they can then check the compliance box. Getting them to think about Lambda means getting them to think about changing the design of their software system. That's harder because a lot of people are really comfortable with their PHP or Cold Fusion or Python front end talking to an SQL back end. You really want to break it up, and whether it's doing container microservices or Lambda microservices, it's a different way of thinking. That's harder. I think you have to appeal to the coders and the engineers to say, look at the things you can do. And maybe this is just the way I've always operated. Like, nobody at NASA wanted to let me use Python 10 years ago. We just started using it and showing that we were kicking every other developer's ass. And then all of a sudden, other people started looking at it a little more seriously. So I think demonstration by example is the only way to really sell it. And I think when you say 80% cost reduction and improved security and no pagers, that helps. I think you have to appeal to the bean counters about cost, security people about security, and then developers and architects. But the architects are going to have it takes a while to twist your brain around it.
So you anticipate for your next NASA project it's going to be easier?
I hope so, and our security group's pretty reasonable, and we've seen them since we did this. They're starting to deploy all sorts of little security tools and checks in Lambda. Because why would you run an EC2 instance 24/7 when you're just going to scan a couple of hosts an hour, or a couple hundred hosts an hour? It's much cheaper this way, and it's fire and forget. Scaling is great. So I think engineers get it once they see what you can do. But I think demonstration is probably the best way to do it. Even if you can just do like a less than minimal viable product. Oh, you know that application you got? What if we try this approach? And it's like, wow. Because you can build this stuff pretty quickly, especially if you don't have to worry about error recovery and that sort of thing, because the scaling happens. So I think security is one of the easier sells for us because we have a sane security team.
There's definitely a lot of government customers in the cloud doing stuff. And NASA's been out a lot of the reinvents over the last couple of years. Is it Stratus?
Yeah.
So working with Stratus, talking about some of their authentication stuff. So getting up there and talking about their security and being in the cloud. So it's kind of weird when you're talking about, you had all these challenges being able to get access when they're up there talking about the great access system they have.
Yeah, the silly thing is we built the GovCloud for them and then they cut us off.
Yeah.
But we had access to the commercial cloud when we were developing this, so we could see all the logs and all the cloud watch and on everything else. And that was we couldn't have developed without the visibility that we had. And if you're forced to develop in GovCloud, so we developed in private or public cloud and then moved over the code. Yeah.
You set me up perfectly for this next question. With the speech. Challenges moving from commercial to GovCloud, knowing that the same resources aren't in there. Did you guys run into anything where you're like, oh, I didn't realize this wasn't available in GovCloud?
We're going to start by having the EVA's systems give us things through an API gateway. It's like, great, wired it up, and then go to deploy it in GovCloud. It's like, there's no API gateway. It's like, and they look at me, it's like, no, Lambda just landed last week. And you want API gateway too? Next you want Cognito. So things lag, and that's the biggest killer.
Have you heard of a company called Digital Age Technologies that created a product called Shift? So they mock out different AWS environments. So they'll have like a mock-up, C2S, all the different like networks, and you can like run your code against there, and they'll like let you know if like that service exists. So, like when you're developing.
It's like the can I use on browsers.
Yeah.
Interesting.
It's called Shift. It's by Digital Age Technologies. It's one of our sister companies.
I hadn't heard of it now.
Virginia, I think Koya Systems has a similar product.
Okay. So they do
basically, they make a C2S emulator essentially.
I think it also helps to call up your local friendly AWS rep and say, hey, I know API Gateway isn't in there yet, but can you give me like a quarter estimate of when it is? Because if I can start building it now and know that it'll be ready, like we're doing that with TechStract right now. It's like we're building everything in GovCloud and showing NASA that the technology works and can benefit them. So if we know that it's going to take us 6 months to build them a system, and then Amazon's going to have TechStract available in about 6 months, then we can get ahead of the curve.
You must be new you must be new in this environment. I mean, it's always the security guys, and there's no penetrating their process. Eventually, something will just come down the chimney and boop, it'll land on your desk.
Sometimes it's dragging them. It's figuring out how to incorporate them. I mean, that's a big problem, whether it's the government side, the public sector side, or private sector side. I came from the security team, and I got into AWS because one of our teams was like, hey, we're doing this stuff. What do you think about it? I was like, I don't know anything about AWS, but that's pretty cool. So I jumped teams and went over to our CTO team who was really playing with all this stuff and learned it. So then going back to our security team, it's like, here's things you got to understand and trying to educate them on how all this works.
I've done a lot of, in previous life, sysadmin and security, and I got paid for several months to come back to NASA after I left and break into NASA. So I'm sensitive to the security concerns, and I try and code a little bit more defensively probably than some people, and I know a bunch more networking than a lot of people. So I'm happy to work with security folks who do have these concerns because I get it. And I understand the VPC and network egress stuff. So I can talk enough of their language, but you have to learn their concerns and try and accommodate.
The other side I'm trying to do now is like, how do I put stuff in front of the developers or the DevOps folks and say, here's things you got to understand. So it's serverless security. This is like one of my areas I'm trying to work on now. It's like, here's some concepts, things you got to think about as you're developing your code. How are you going to do this, this, and this? It's not just do anything you want, but you got to take this stuff into account and think about your logging and this and how you're going to troubleshoot.
But it's good thing that logging happens for you, which is like, oh,
at some level,
great.
But
I don't lose my syslogs.
So like you're at somewhere in your function, things are breaking, you want to know where it is. You still have to output those logs somehow, but are you thinking about that in your code? Where am I going to put that? Well, you can't get to your CloudWatch logs if you use the logging facility.
I think instrumentation observability is a huge thing right now. There's some really smart companies working in that space because things like Lambda or Kubernetes are intractable when you have hundreds of systems all running. Where do the logs go, and how do you aggregate them, and how do you find out that this 17 systems touch this one job?
The hard part is also correlating log input, but log output with data input.
Oh, I'm fighting with that with a little application we're working on because I get the people writing the code aren't putting any contextual information in there.
Well, I mean,
so I just see streams of data. Like, where did this? Which part of your hundreds of lines of thousands of lines of Python or modules, and where did this happen? You can't find it.
I think that's why DevOps is a good thing because it forces you to own it cradle to grave. If you write shitty logs and you have to debug it, you're going to fix those logs.
Well, that's not enough though, because you can have very nice logs, log output, stack trace, illegal character at this location, the input file, without having access to the input file.
Well, it sounds like a Microsoft error. File not found. Would you care to tell me which file was not found? Is it exec.bat?
And this is one of the problems. Like, if you're going to try to fix a problem, the first thing you're going to try and do is recreate it. And without being able to keep track of all of that, essentially job tickets of what you actually did. And this is where you kind of need a central log controller, job controller, just keep track of where you are on the various jobs, just to know and keep track of what the input is, so you can go backwards and replay it.
We're doing that with the S3 metadata that I mentioned. So when the job comes in, we give it some transaction ID and stick it on the S3 metadata. And each time we create a new S3 file, we propagate those metadata from each S3 to the next S3. So we get some traceability, a traceability number basically.
Yeah, and obviously if you're data sensitive, you can't do it. But one of the nice things to do is to log the event that comes into Lambda. That way it's super easy to replay it, especially if you do it in JSON, throw it back in a test, and just hit test, and you can replay that exact event.
So I think of it as in terms of the auto assembly line, where you got an automobile coming down there, and it's got a ticket attached to it, as basically people mark it off as they put in the right engine, they know what needs to get done, and you basically pass these around through the Lambda queuing system, so you can keep track of what it is that you're working on and some contextual metadata, and that's part of the input to all the Lambda functions, as well as what it shoves out, to say who's the next guy to go. And that way, when one of them craps out, it can actually put, as I'm running job number 572, it's at state 16, here's what the input is overall, and they can restart them and things like that.
So it means that along with that, the architecture, we have to add some of the more services like SQS, SNS, add services. So as soon as the log is increasing, one log event has happened, it should attach with that the SNS, so that notification has to go, and the SQS will tell that keep on sequencing. That should be a part of your architecture.
So what I think is,
depends upon.
If I were going to make suggestions to changes here, the attachment of Lambda functions to S3 bucket events is like a cheap and easy way to essentially make this little mini ticket. Somebody put this little thing in the bucket. And if you sort of split that out and made your own tickets through using SQS directly, and now I can actually put as much metadata in there as I want. I'm not limited to just what I can, cram in the margins on an S3 bucket.
Right. I mean, you can track it with Dynamo DB as well, and I think one of the things that we're really hoping helps us is with orchestration and finding where it fails, is we're moving to use step functions, which is a workflow engine. It's pretty cool. You can define a very complicated work function in a handful of YAML statements, and it maps out in a graphical format in the console for you. And you can create this with just pass statements, so you can see what your workflow is visually. And then at each step, you can say, okay, you invoke this Lambda function, you do this function, you do this function, you wait for this callback before you resume the state function, like in our case, like OCR. It's going to take a while, 500 pages. Instead of this counting hack that I wrote, we want to use the state machine to do that for us and wait for us to have all the pages before it resumes the next phase. So the step functions has tracking built in. You can see where it failed or how far it got, and you can propagate out what happened. And they also have X-ray that's supposed to do a much more deeper dive into that. I haven't started using that yet. Yeah.
Sounds like you started working with Dynamo. I just started playing with it. Have you gotten to the part where you're to provision RCUs WCUs, and how do you think how does it scale for you so far? Because I'm worried about, I started looking at it for billions of events a day, and it's not.
We
got really expensive.
We used it very badly for images NASA Gov because we'd used MongoDB, but that's a different beast. We were pretty comfortable with SQL. We're trying to use Dynamo sort of like an SQL DB. As we came up with the exactly wrong data model. The things we needed to ask were not things we built indexes for. The things we don't want to ask, we got an index for that. Hell, I can tell you that whether it's an image or video. We can't tell you where it lives on the S3 file system. So I'm learning a lot more about how to develop data models on Dynamo. Take a look at a YouTube video called DAT 101 from reInvent a couple years ago. Rick Houlihan. It will blow your mind when he starts putting like all of Audible.com's schemas and data models into one DynamoDB table, and that is actually best practice, putting all your tables into one table.
Yeah, you kind of limit that. I've been looking at some of those things. I have a hard time
wrapping
my head around that thing.
I've watched that 10 times.
It's like, you're doing what? Because I'm used to SQL, and you're just like, how? And then it's stuff. So it's,
and they just released 2 days ago DynamoDB Data Workbench, or Workbench, I think, which you can run locally, and basically you can define schemas on your local laptop and put some test data in and see if the indices you build do the queries you want. But with Dynamo, what basically everybody says, like, unlike SQL, you put all your data in and you don't know how you're going to get it out. You don't know what questions. So at query time, you assemble the query, and that's very expensive, and that's why it doesn't scale. I mean, really scale. DynamoDB, you need to think about what your access patterns are going to be and do the modeling based on that, create the indices. But you can do a lot of weird things by using compound keys, a partition key and sort keys, and the sort keys can have multiple different parts in it, like a date, hashtag, status, hashtag, something else. And you can say, oh, find me all the stuff with this date. Find me all this date with this date done, or date failed. And you can do crazy queries on this stuff that way. Watch the video. I wish someone would give a talk with one of these groups. And what we need to do is have some kind of like hands-on workshop, because it's hard.
Yeah, it's like I'm watching it. Okay, I kind of see it, but it's hard.
Yeah.
But you talk about the throttling, and we DOSed ourselves with our app because they had set whatever reads at a certain level, and then the app stopped working.
Yeah.
I could figure it out, and I just happened to go to CloudWatch Metrics, and I saw a spike that's like throttled events. I'm like, wait a minute, that's about the time you said the app stopped working.
Yeah. So we used it for Images NASA Gov, and we used it badly. So one of the things we had to do with Images NASA Gov is find the most recent and find the most popular assets. And so what we do is, because we didn't use it properly, we said, well, we're just going to query it, find the most recent things, and sort by date reverse, limit 10. Can't do that. We scan the entire table of every single asset, look at the date, sort, compare. It's like horrible. So it takes like 5 minutes to run through the scan, and it's very expensive. So we just crank up those read units, and then occasionally we have so many assets that we run out of read units, and it bombs. And Charles wrote in this retrying thing to retry the retry that's already built in to Dynamo. And it's like, we're obviously doing it wrong. So Dynamo now has two different things. They have an auto-scaling thing, where if you turn on auto-scaling, it'll increase and decrease your capacity units for you. They also have like just what do they call it? Basically it's free. Not free, but there is no limit. You just use it, and you get charged based on usage, which is great, unless you're doing something wrong, in which case you get this huge bill because you're accessing it wrong. It also costs maybe 70% more doing this unrestricted thing, but I think for most applications, unless you got some runaway code, it's probably better than trying to chase this the read and write capacity units.
Yeah.
Certainly, at least in development, test the shit out of it and see what the patterns are.
Auto-scaling works, but it can lag.
Yeah, it does lag, has to lag.
Yeah.
Because they're creating new partition backends for you.
Yeah, they're watching CloudWatch metrics too, so they're watching your metrics, and if you scale too fast, they can't keep up with,
right.
Or
But at least they're doing that for you.
Yeah.
Because there used to be all these hacks where people were doing that themselves. They say, okay, I'm going to make the API call that increases my units. So they just built that in. There's also a DAX. If you're doing read, it's basically a cache. It's a Dynamodb API call compatible cache in front of Dynamodb. That only useful for reads.
but you're running EC2 instances then.
It's doing it.
It's, yeah.
So I don't care. I don't have to run it. That's good. It's a service.
Yeah, if you're not using like the VPCs, now you got now you got to start thinking about how that interconnects, because they were looking at, well, how can I solve our problem? Somebody said, well, DAX will solve our bad SQL calls in Dynamo they were doing.
But there's tons of people doing IoT and video games and mobile app stuff that's tracking like millions of things an hour, and just huge. And I guess that's the one time when Amazon says, it's okay to use a second table, like one for all the data and one for all the time series measurements, the telemetry. And there's completely different ways to use it when you're doing that sort of time series thing, and they've got a bunch of blog posts on it. But also, I was talking with some AWS reps. They had a pop-up loft in Northern Virginia the past couple of weeks, and I was bugging. They had a couple of solutions architects there. And I just started hammering with questions, and they knew the answers. I said, I think maybe if you want to do this like this, and you might want to do it with that, you should try to take a look like this. And they said, solutions architects are free to use. You don't get a lot of time with them. But if you come in with a well-defined problem and say, here's what my access patterns are, they can work with you to design a solution, and then take that home, try it a couple times, do some of your own work, and then come back and say, okay, here's what I'm seeing. So that's what they recommend doing. It's like, you got to get them on the phone, or come to any of these events that they host, because there's always going to be a solution architect there. Even if it's like Cloud 101, it's like, I got that. There's going to be a solution architect there. And that was their recommendation to me. All these ones around DC for like suits, there's going to have to be a solutions architect that suits aren't talking to.
Good point.
Anything else?
Just like one last one.
Sure.
If you have time, I'd be curious to hear what your CI/CD stack was like.
For a commercial, we're using Circle CI,
Okay.
and that's fairly easy to use. In our NASA cloud, the contractor has provided us with Atlassian's Bamboo and a very poorly implemented version of it. You get exposed to the underlying OS. So when we build in there, that's not the OS we're deploying to. So it might work there on their Red Hat, but when we go to deploy it on our EC2 running Ubuntu, it might not work.
Okay.
So Circle CI does everything in containers. So you say, my target is Ubuntu 16, so give me a Ubuntu flavored container, and I'm going to run in that.
They don't run in containers.
Our people don't run it that way. Yeah. Badly configured. I know Atlassian's not that horrible. But yeah, so we got it running. We were the only people in their CI/CD system for years. So when we said like this shit doesn't work, it's like, so you're one of several customers, many customers. What else?
Yeah, that is the downside of let somebody else do it, because they'll do it on their priority schedule.
Mm-hmm. Yeah, because I am sometimes impressed with how fast Amazon moves, though. They released this Dynamo DB Workbench, or whatever it's called, and I saw 2 blog posts saying, it looks great, but it just trashed my AWS credentials file. Apparently, didn't like AWS key ID equals blob with no space. It just destroyed the file. So I saw 2 people report on it, and the next day I said, here's a fix. That's pretty fast. But it was released as alpha. My dog ate my homework. Alrighty. So if you like reaching out, Twitter, LinkedIn, SlideShare, and I'll post, these are already on SlideShare from when I did this at the AWS Public Sector Summit. I'll post it out to the meetup anyway.
Okay, cool.
And one of the guys who's organizing the AWS Meetup, Serverless Meetup in Arlington on the 30th, I'm going to be doing the same talk there. So if you really can't get enough of this or know friends who want more, send them my way.